So yeah, we're really excited to be here to share some of the successes around performance we've had at Intuit. Our story begins like this. We spent about a year to optimize the top 50 pages for 6 of our marketing sites. And we were able to reach, in some cases, speeds as fast as 2 seconds. I'm Jae Hung. I'm an ex-Yahoo engineer. I was actually lucky enough to be there when Steve was doing his research on performance, and that's where I picked up a lot of the performance.
And I'm Norbert, not Norbeth. I'm a guy, not a gal. I do full stack development. At Intuit, I do front end and performance.
Okay, so to start, let's take you back to the early days. Intuit.com started around the mid-'90s. This is a screenshot from 1999. The site was built in an era when this was top-of-the-line cell phone technology. I'm probably dating myself, but I owned one of those, and I thought it was pretty cool at the time. It was data technology. It was before we had web standards. Right. So we had this one site, and over the years, we had lots of stuff happen to this site, new developers, new code, and we ended up with many sites, all running on the same code base. And that code base looked kind of like this. Right. It was big, it was bloated, we had stuff connecting to each other everywhere. It was about as maintainable as that. Right. It was also slow. Right. HTTP archive had us pegged at 15 seconds. There's a lot of negative things that came as a result of the poor performance, user experience, SEO, our page views were down, conversions were down. Worst of all, it was just embarrassing. We knew something had to be done. Engineering presented a case, and we cited experts like Steve Souders. We cited research from Google, Bing, Yahoo, infinitely long number of blog posts, but nobody got it. Right? We just couldn't get people to buy in. Everybody was too busy. Nobody had any time, nobody had resources. I'm sure it probably sounds familiar to some of you. Okay. This changed one day. We had a frustrated engineer who, in his own time, started to optimize some of the pages. We had a successful A/B test that showed that this faster page actually improved our metrics. Right? All of a sudden, our conversation went from not interested to, hey, how fast can we optimize everything? Right? We cited examples from external sources, and people didn't get it. But once we were able to show internal examples, and people got it. Okay. I think you guys know this guy. So this is the performance golden rule. Steve Souders said this back in 2007 or so, I think. It still holds true today. It basically says most of your users spend most of their time on the front end, and you need to start there. Right? But before we can start there, we needed to compare apples to apples. And what I mean by that is we were successful in getting a lot of people talking about performance now, and everybody was saying stuff that sounded kind of similar but really wasn't exactly the same. Right? We had server response times mixed in with front-end page load times. We were mixing numbers from browser tools versus proxy tools, and just we needed to get on the same page. Okay, so we had to set some common ground, and what we said was the page load times we're going to talk about are going to be all front end, right? All client-side page load time. We're going to stick with a common tool, which is webpagetest.org. Some of you guys may have heard of that. The reality is we use multiple tools, but in sharing out our numbers in terms of keeping track of our performance, we went with web page test numbers. Okay. DSL connection speed was what we standardized on. Now we've shifted over to cable to kind of keep up with everybody else. I think the industry has moved over towards cable, but at the time, DSL was the speed that we said we would use. Okay. We settled on using a doc complete load time. Pulling in different third-party components, we had no control over what happened sometimes after onload, but we knew up to doc complete we can control most of that, so that's what we used. And then we used an average of 9 iterations. So we actually used 5 before Steve came in and gave his talk. He used 9. We figured Steve's using 9, we'll switch to 9. So, okay. Now that we're on the same page, we set a goal, right? And the goal was to reduce the page load times for the top 50 pages for 6 of our marketing sites by about 50%. At that time, our page load times were about 12 to 15 seconds, so the goal was 6 seconds. Okay. So to start this phase, we took a look at the usual suspects, right? And to us, the usual suspects were the original rules of high performance that Steve wrote in his first book, right? And there's 14 different rules. A few of these we've grayed out because we didn't really focus a lot of attention on that. We added a few extra items on the bottom. We won't have enough time to go over all of these, but we're just going to share some of the big wins that we've had and also some of our mistakes. Okay, so this is a typical page, right? It's quite long. Lots of requests happening, lots of redirects. All of the yellow highlights are all redirects, right? And this is kind of what it looked like. You know, we had pages upwards of a meg, sometimes up to 2. Lots of images, right? 60 to 70% sometimes of our page weight was in images. Lots and lots of CSS and JS files. Our JavaScript was regularly over 400K, right? Lots of redirects and just overall lots of requests, right? The first rule of performance from Steve Styler's list was to minimize HTTP requests, so that's kind of what we started. Okay. The general problem with the request is that it has overhead, right? You have to set it up, tear it down, make a connection, etc. Okay. Our problem was we had lots of these going on a page. We started by merging and minifying the CSS and the JS files. And what we found was this was not that easy, right? We had lots of stuff going on in this code base. You know, we had lots of shared files, lots of copy and paste variations, document rights everywhere. It just became very difficult to combine all of these files together and load them on a page and still have everything work correctly, right? We had bleeding and collisions everywhere. Okay. So we solved this. We solved this by cleaning and refactoring all the CS and JavaScript. We made sure we added all the CSS containment classes that we needed to prevent styles from bleeding to each other, namespace or JavaScript or variables. We optimized a number of DOM traversals just to speed up some of the code. We created what we called a global merge set, and this is where we put code that was shared across all 6 of the sites. And then we created something called a site global merge set, which is where we shared all the code shared across all the pages of one site. Okay. And this ended up being a big win for us, but it came at a bit of a cost. Right? The CSS JS containment took a really long time. You know, these 2 Uber merge sets that we had, you know, for code for across all 6 sites and code across all pages of one site meant there were a lot of pages that were loading a lot of code that it didn't run, right? It didn't need. You know, so that was something we had to, that was one of the costs that we had to pay. What we found was these top 50 pages that we focused on in the files that we were combining from these pages were also being used by other pages outside of our top 50. So stuff just started to break, right? And it gets even worse. We found that other sites outside of our department in Intuit were also linking to our files. And we had no idea that these places were linking to our files, right? So once we made a commit, everything broke. We get the call. We had to deal with it. It took a really long time to actually get this to happen, but you know, we got it done, and I said it was a big win. We probably reduced some of the CSS JS includes by a factor of 10. Okay. So next we moved on to spriting images. Right? So we all know spriting is a good thing, right? You take multiple images, you combine them into one, you know, save on your requests, right? So let's see how we did. So this image is an example of a sprite that's probably a little too excessive. This single image right here is 306K. And it's 306K because we saved it as a 24-bit ping, and that's because there's some alpha transparency here. We were lucky enough that we had a design team that was pretty flexible. We explained the problem to them, and we modified the image. So we were then able to save this as a JPEG, and that resulted in a file that was less than 50K, right? So we saved over 250K from one image. You know, and when I think about 250K, I just think it's, for one image, that's a massive, massive number, right? If a page load is about a meg, you just spent 25% of that page load on one image. Here's another example. This one's not quite as bad. This was also a 24-bit ping, and the reason for that was because of this image right here. Had a little alpha transparency around the border. What we found was that this image was only delivered to people who didn't have Flash, right? And because this image had alpha transparency, it caused the entire image to be saved as a 24-bit ping, and everybody had to pay the price for what a very small percentage user would have saw. Okay. So we could have solved this the same way. We could have saved it as a JPEG, removed the alpha transparency. But the first two images on this slide were actually poster frames that were displayed in the video player before the video played. So what we ended up doing was pulling the video player button out, which is the only difference between the two versions of this image. And we were able to save quite a bit. The total solution ended up being less than 20K. It gets worse. So this is a massive, massive sprite. This is kind of what it comes up with. Each one of these images is a screenshot of a product. And the worst part of this is that we didn't use the same image on the same page. So we didn't really need to spray that together for that page, right? And the total file size was 5 megs. So if you're unlucky enough to land on this page or any of these pages that show one of these screens, you had to pay 5 megs, right? So that's just 5 megs of RAW. So my point in showing you these examples is that our team took spriting to heart, but we didn't make the best decisions in some of those cases. And we learned from that. You need to sprite correctly, sprite intelligently, make sure you combine the right images that need to be together, and use the right bit rates for your images. Okay. CDN. So the good thing was Intuit was already using a CDN. We were using Akamai. Our problem was it wasn't configured properly. We didn't have everything that was gzip, and not everything had an expired header set on it. Even though we had a CDN, we didn't load everything from the CDN, right? So we were still going back to our application servers to load certain files. In some cases, we would load the same file, but one from each location. The user had to pay double the cost for that image. Okay. All of our sites share the same CDN domain, so organization became a little tricky in terms of file management. Before I come back to how we fixed that, I want to talk about something called the angry cookie monster. So we all know that domain cookies are passed with every HTTP request, right? And this was our domain that we use right here. So not only for all 6 sites of ours that set cookies, we also had to deal with cookies that were set from some of our applications or products who were always using Intuit.com domain, right? We estimated on our own sites an average cookie was about 800 bytes to a K. If you multiply that out by an average of 100K, 100 requests, you're sending about 100K worth of data for static assets that you don't need to send over the wire. Okay. So we eventually solved this. We reconfigured Akamai. We made sure that all the right configuration settings were in place. This is actually a pretty low-hanging fruit for us. We made sure that all of our static assets were loaded from the CDN so that we were no longer paying twice for the same file. And we moved to a cookieless domain, which we can see here. And our naming convention allowed us to have a separate domain per property, as well as an ability to shard. Okay. Next, we have beacons and redirects. So these were marketing sites that we were working on, and that meant we tracked everything, right? There's a beacon for everything. Anybody that came in from any sort of channel, we would have to put a tracking pixel for. Our problem, we had lots of these that were going on the page. Quite a bit of these have 302 redirects. You would pay extra costs just to pull that tracking pixel in, right? Over the years, it just grew and grew, right? It's very common for a new marketing campaign to show up, and a marketer would say, hey, we have a new campaign. We need you to drop this tracking pixel in. But when the campaign ended, nobody came back and said, hey, this is over. We need to remove that pixel, right? So we had lots of legacy stuff floating around. Okay, so how do we solve this? We took an inventory of all the beacons, right? And then we benchmark all the beacons so we can know the relative cost of each one. We presented this list to the marketers and asked them to review that and let us know any of them which didn't apply anymore, or to tell us better which ones needed to stay, right? We were successful in removing some of these beacons, but for the ones that we had to keep, we actually reached out to some of those vendors, and in some cases, they responded and were able to replace some of the code that we used, right? So we were able to get better performance. Okay. We went from probably about 20 to 30 beacons down to about 8 to 10. We did some other optimizations as well. I'm not going to get into this too much, but at the end of the day, we eventually hit 6 seconds, right? Everybody was happy. We were starting to see some positive results from it. That was pretty short-lived, though, right? The question finally came up. Can we go a little faster? Right. So now I'm going to throw this over to Norbert. He's going to talk to you about how we went faster.
Oops. Thank you, Jay. So, as Jay mentioned, took us roughly 6 months worth of optimization to go from 15 seconds to about 6 seconds for 50 URLs. And right after that, it was a pretty good time. And 2 things happened. First of all, walking around the office, we would pretty much see this kind of face all the time. What's the big deal, you may wonder? Well, at 6 seconds compared to 15 seconds, we saw measurable improvements and benefits to the business. We saw an increased number of conversions. We saw a better user experience. So this was totally justified. Jay will talk about some numbers pretty soon. But as soon as the enthusiasm wore off, people started doing some analysis. And the question of the day was, what would be the potential business upside if we got closer or under to 4 seconds? The situation was drastically different from a few months before. We weren't begging them to do performance optimization. It was the other way around. They were coming to us and asking us to make things faster. This is a highly scientific chart of our progress over the past few months. So we went from 15 seconds to about 6 seconds, and now we were in the position where people were asking for more. So no one knew what faster was, but we decided to do a special experiment and shoot for about 2 seconds on 2 of our most popular pages. Why 2 seconds? Well, we knew that there would be a point of diminishing returns. That would be a point where even if our pages were faster, we wouldn't see any measurable business impact. We also looked across the fence at Google, literally across the fence from Intuit. And we saw that their sites, world-class sites, they load in about 3 seconds or faster. So we decided to do 2 seconds just to see if we could do it. One of the first things that we agreed upon is that one-size-fits-all approach will only have a limited amount of effectiveness. We've already done all the generic stuff, and it helped a lot. And we had to come up with new rules. So the new rule is go beyond the rules. In order to be successful at reaching 4 seconds and 2 seconds, we had to address problems that are specific to Intuit. We performed a deep analysis of every single component, and we started looking for bottlenecks. I'm not serving any beer now, but that looks pretty cool. We did find a bunch of issues. I will focus on the 4 most pressing ones. Given that we're a marketing division, there is a lot of A/B testing going on. Unfortunately, the A/B testing software was a case study of inefficiency. We had a bunch of video players. They were not good. I mean, a video player is supposed to play video. These were doing much more than that. We had a global header whose inefficiency would easily spawn a book and a Hollywood movie. And then we had a bunch of inefficient JavaScript. So let's go through the list one by one. This is our A/B testing software. Generally, with an A/B test, you serve different content to different users. You have your control. That's the default content. Then you have any number of use cases. If users fall into that test case, they will see different content. So let's look at what's happening here. As you see, we have a number of blocking calls in a staircase pattern. Let's look at them in more detail. Each call goes to the test server to check if the user falls into a test case. In the example here, the user doesn't fall into any test case, so these calls all return empty. There are 5 calls here with 3 more on the previous slide. The total of these calls is 750 milliseconds. So that's 3/4 of a second to get nothing. That's the new definition of boring. If the user did fall into a test category, the request would take longer because there would be test content that would have to be downloaded. So I mentioned earlier about the control. This is how it works. If you're unlucky enough to fall into a test case, you would see the default content, and then you would see the test content. So you'd have to wait twice in order to get the content that you need. So everyone pays the price for default content whether they see it or not. On top of that, this testing software had a pretty poor performance architecture. Here's how it was set up. There was a div, and then below the div, there was some JavaScript that was making the server call to get the content. Now imagine a lot of those on the page. Guess what happens? Once the content is received, you do a DOM traversal, and then you inject your content into that class. There is no search by ID. You do DOM traversals over and over and over again. That was pretty bad. So how did we fix this? We did a seek and destroy. What do I mean by that? We just took an inventory of all these calls. We talked to marketers. We saw what we could remove. There were a lot of these tests that weren't used anymore. We removed all the expired tests. We commented out inactive tests. And the only solution to fix this for good was to switch to testing software. So a lot of people are using third-party software. Before doing that, check what it does, because oftentimes there are a lot of surprises. We did have one pretty bad case here. Let's look at the video players. We had a bunch of video players. I think this is the worst one of them. A video player is just supposed to play video. Well, guess what? This video player comes with an entourage. At number 1 there, you actually see a Swift file. That's the actual video player, which takes about 6 to 8 seconds to load. And then you have a bunch of redirects, a bunch of beacons, a bunch of tracking requests, about 23 of them. I mean, even the NSA would have trouble keeping track of everything that's going on here. On top of that, the entire page is blocked while all of this is going on. Entourages are expensive, and this example is not any different. The parent page has to pay the price for loading this video player. It's poor for performance, bunch of callouts. How did we fix this? We basically replaced all the video players with just one, and on top of that, we lazy loaded it. If you cannot replace your video players, at least lazy load them so that the price is not paid while the page is rendering. Here is another whopper. This is third-party developed software. It was a header that was developed for Intuit, and it was named World Class Nav. We suspected that it might be a bottleneck. We didn't know how bad it would be, so we popped the hood and we took a look inside. Here's what we found. 2 A/B tests, the ones that we talked about earlier. Sprites instead of CSS. Hundreds of event listeners. Over 1,100 DOM elements. Now guess what? The entire page had 1,800 DOM elements. So only the header was consuming about 65% of that. This was happening on every page. And we did an experiment just with the header on a blank page. It loaded in over 5 seconds. Right? So I'm pretty sure that's not a world-class, probably a worst-class header, right? How did we fix it? We did a full replacement. We utilized web standards that minimized DOM traversals. We minimized image utilization. We used event delegation. Across the board, every page gained between 1 and 1.5 seconds of improved time. And that's the look of the new header below. It's not that different. I think it's even prettier than the worst class header that we've had before. One of the final steps we took in our optimization journey was experimentation with Control.js. Control.js was created by Steve to give developers better control over how JavaScript downloads and executes. This is a fairly popular topic among performance-minded web developers. When scripts are downloaded with a regular script tag, they block resource downloads in certain browsers and page rendering in all browsers. Asynchronous downloads mitigate the issue to a certain extent, but once downloaded, the script will begin its execution phase. The issue with the execution phase is that while the browser is parsing and executing JavaScript, it cannot do much else. That's where Control.js comes in. It downloads scripts as images or objects, depending on the browsers, and if proper caching headers exist and the response is cached on the client, then it can be later inserted as a script element. We used Control.js on a couple of pages on two of Intuit's properties, QuickBooks Online and QuickBooks. Including other optimizations, we achieved a mid 2-second load time for these pages. So we did get into the 2-second range. Since Control.js changes the way we think about JavaScript in terms of parsing and execution, while we were happy with the results, we thought that we weren't ready as a company to implement this on a wider scale. Up until now, we talked about single pages. We also took a look at flows, such as what happens when the user logs in or they go through a conversion funnel. For example, the Intuit payment site, it went through a redesign. The product pages had large, vibrant imagery. So on predetermined flows, we knew we could optimize load times. So how does it work? While the user is idling and typing stuff into form fields, we prefetch assets for the next page because we know what the next page is going to be. And we do this throughout the entire flow. So that helps to create a better user experience and faster load time for subsequent pages. Finally, we did a bunch of other optimizations. We did lots of lazy loading wherever we could for stuff that's below the fold. We did automated performance monitoring. I'm not going to talk about everything here, but that's a snapshot of everything that we've done. And now, how did we do after we did all that work? Here's where Intuit.com was on February 15, 2012. It was at 15 seconds. It took about 2.3 seconds for the site to start rendering. A little over a year later, it was at 3.6 seconds, 1.7 seconds start render time. And there you see a screenshot of the two sites. They're not vastly different, but much, much faster, 5 times faster. Let's take a different look at this. This is from Web Page Test. It shows how the site is loading. 3 seconds, you've got nothing. You stared for 3 seconds, nothing happened. 4 seconds, you got the worst class header who's greeting you. 15 seconds, almost there. 16 seconds, page complete. That's embarrassing. Fast forward to a year later, boom, 3 seconds, everything is there. This is just with the stuff that we've done. No other magic. Payments.intuit.com. In 2012, it was loading in about 10 seconds. A year later, it was loading in 1.7 seconds. Guess what? Over 5 times faster. And finally, this is the only chart that I'm glad to share with my bosses. It has a downward trend, you know. I didn't feel bad about sharing this in a meeting. It shows how the times improved from about the 10-second range to 2-3 seconds a year later for the home pages of the 6 properties that we worked on. And to talk about business impact for everything that we've done, Jay.
Thank you. So yeah, as you can see, we were able to get some good successes on page load and performance. But what's that mean for our business? Right. One thing that we know is performance is tough to measure. Right. Now that we've got faster sites, we had a lot of talk around the office, and it's like, oh, our pages are so much faster. We're seeing positive improvements. But when we try to dig in and figure out exactly, what came from performance, it was really hard to figure out. Right. It's very difficult to credit any sort of lift that we see as coming strictly from performance. The best way to do that, obviously, is if you don't make any other changes, except for performance changes. But good luck with that, right? Most of us can't. We don't have that luxury. Nevertheless, we did find a few examples I'd like to share. This is for one of our in-product purchases, right? So users of QuickBooks Online would see this module on their screen, and they can click on this top link here to turn on payroll. Essentially, they're going to sign up for the payroll service and add that to their account. We do a lookup on the server to see what kind of upgrade path that the users qualifies for, and then we show them some landing pages, right, which allows them to complete their purchase. This flow here took about 9 to 12 seconds, right? But it didn't always take 9 to 12 seconds. It actually loaded at 3 to 4 seconds at one point. We launched a new platform. A lot of the performance changes that we have put in there were not part of that new launch, and it regressed, right? And we saw that when the page load times went up, our conversions went down, right? So engineering got on it. We started to do the optimization, reapply the work that we had done before, and we had some good results. We saw that when we brought the performance time back down to 5 to 6 seconds, it wasn't quite as fast as we were before, but still much better than 9 to 12. Our conversions went up, right? And it went up 14% in the week right after we made this launch. And the only thing that was different from week to week was performance. Okay. Here's another chart of our shopping cart checkouts. So this shows the completion rate of people who entered our checkout process that actually completed that checkout process. This first section right here where it dips up, the blue line dips up, we had just launched a new platform and didn't have our performance changes. We actually had some tracking issues here, so that we falsely counted certain completion rate. We fixed that. We fixed that right here at the beginning of this red section, and we can see that the conversions had gone down. Right, the pages were slow during this period, and the conversion rates had gone down. Again, our engineers came in. We re-optimized it, reapplied the performance optimizations from before, and we see in this last section here that we bumped that back up. Right, and this was the closest that we were able to come to where the completion rate was for the year prior. Okay. And the only difference here in this case was performance as well. Okay. Here's our QuickBooks Online sign-up flow. Most people come here to our marketing page, the item on the left. They click on one of the Buy Now buttons, and they enter our sign-up flow. Right, it's a few steps. And at the end, you land into the application page. Okay. So this is kind of what it looked like, right? Each page roughly had about 6 seconds or so average load time. This 8 seconds here in the orange arrow right here actually shows what happens after you've entered your credit card. Our system basically creates an empty company for you and then drops you into the application page for QuickBooks, where you can now enter data for your company. And that process took about 8 seconds. So the total for this entire flow was maybe 35 to 40 seconds. Okay. And what we found was when we were able to improve this entire flow, at least just the page load times, by 2 seconds or so, our conversions went up by 10%. And that was for a quarter where the product team actually looked into it. We were trying to figure out where do we get this lift from, and the only difference that we found was that we had faster loading pages. Generally, this is what we found. For every 1 second of performance, if your original page load time was above 7 seconds, but your final page load time is 5 seconds or faster, we saw about a 3% conversion. Right? If your original page was faster than 7 seconds but slower than 5, we saw 2. And if your original page load was 4 seconds, and we saw 1%. So you can see that we have diminishing returns as your page got faster. Right? Now for some takeaways. Getting buy-in, right? It took us a little while to get the buy-in. All I can say is stick with it. It's good to keep evangelizing it, get people talking about performance. It's helpful if you have a champion who's in a position to have some influence, right, in our organizations. In our case, we did experiments. Our experiments had results. We showed that, and that was very helpful. Okay. We started with the usual suspects. It does work. You can have measurable improvements. It's good to maybe clean up your code a little bit before you get into the optimization. That's what we found out the hard way. But it's a good place to start, and you will see some good results. Right. Finally, we had to go deeper than that. We had to figure out exactly what was going on our site and address those issues. Right. You have to do a deep analysis. What Page Test is a great tool to tell you what's happening under the hood. If you don't know what's slow, you're not going to fix it. Right. The waterfall charts are very, very helpful. This is what we found, that we were able to get the best results, right? Knowing what happened on our pages. Dedicated performance team. For us, we set aside a separate team. Our entire purpose for this team was performance, right? And that allowed us to move forward and move the quickest. We didn't have any competing priorities, right? If your organization can afford that, I think that's great. Looks like the slide's a little messed up. I think that's the highest chance of success. I believe, Steve Satters, you advocate for that dedicated performance team, so it's good. It's good to do. Maintaining performance. So I've seen this over and over again. We get in, we speed up a site, we hit our mark, and we walk away, and then the sites regress, right? So in order to keep your site from regressing, you have to always pay attention to what's going on. We did that. We set up monitoring. We had a private instance of WPT running behind a firewall. We had that connected to our Jenkins build server. So we were constantly monitoring our sites, and it would paint a graph that showed our performance over time. Okay, we had weekly dashboards that showed up in our stakeholders. In our stakeholders meeting, performance was talked about, throughout our department. We actually set up a leaderboard wall, which is kind of the cup half full version of the wall of shame. And you can bet that when you were at the bottom of this leaderboard wall, you cared about that if your product fell into that area. Okay. Finally, we'll leave you with our humble opinion. It's a sample size of 2. We believe that 99% of websites can be made faster, right? Most of us, we're not going to be in that 1%. What that means is our chances to have a faster website are very, very good. That's all that we have. Thank you. Thank you. We have time for 2 questions. Steve.
What was the first thing that you as a side project and kind of got the ball rolling?
What was the side project that got the ball rolling?
Yeah, so the question was, what was the person doing who got the side project rolling that got, that triggered performance in the organization? So we had a web developer who worked on Intuit.com, and he was familiar with performance and started to optimize the homepage for Intuit.com. And he was able to see some, limited results, but still positive results. And we were able to tell, in terms of the number of conversions we have from that page versus the page prior. We also saw higher organic traffic coming in from SEO, and we track our rankings in terms of first page of Google results. And we saw that this faster page, after it's been in the wild for a little while, did have a higher ranking than it did before. So those were enough metrics that our business team understood, and that kicked it off. No more questions? Great, thank you. Oh. Sorry.
What were the benchmarks you used for when you're talking about testing beacon and taking that to negotiate that?
Yeah, so we went to our waterfall charts, right, which showed every single request that happened on the page. Because these beacons were in the source code. They were everywhere. We couldn't, we couldn't easily go through the code and find these beacons, right? So we would track for the top 50 pages all of the requests that would happen that were tracking pixels and beacons. We showed our marketing team that list, and then we called out the ones that were very expensive. You know, certain ones you would call your beacon, your include, and then would then 302 redirect into something else, and you would pull 3 or 4 or 5 other things that came in, right? So we presented that to them, we prioritized that, and then we asked them to remove as much as they could, right? By that time, performance was kind of a big deal, at least with our group. Everybody was talking about it, so they actually eagerly went through that, right? Any other questions? No? Okay. Thank you.